Have you ever thrown a paper airplane and watched it glide through the air? It's amazing, isn't it? For a moment, it seems to defy gravity, that invisible force that pulls everything down toward the earth. Flying is like taking that simple paper airplane and giving it the power to stay up in the sky for a very long time. It's not magic, though. It's science. Flight is all about understanding the air around us and using it to lift something heavy like a huge airplane far off the ground. It's a delicate dance between pushing up and being pulled down, and it all starts with a very special shape. To understand how an airplane flies, we first have to think about what it's fighting against. That force is gravity. Gravity is what keeps our feet firmly on the ground and pulls a ball back down when we throw it up. For an airplane to fly, it needs another force to push it upward, and this upward push has to be stronger than gravity's pull. We call this amazing upward force lift. Lift is the secret hero of flight. It's the force that says, "Nope, not today, gravity," and carries the airplane and everyone inside it up into the beautiful blue sky. So where does this incredible lift come from? It comes from the airplane's wings. Airplane wings aren't just flat planks sticking out from the sides, they have a very specific curved shape. This shape is called an airfoil. It's designed to be a little bit curved on the top and flatter on the bottom. This special design is the key to making the air work for the airplane, not against it. As the plane moves forward, this shape splits the air, forcing it to travel on two different paths, one over the wing and one under it. And this is where the science gets really cool. The journey of air over the curved top of the wing is a little bit longer than the journey of air under the flat bottom. Because the air molecules going over the top have to travel a longer distance in the same amount of time, they have to move faster. This is explained by something called Bernoulli's principle, which simply says that faster-moving air has lower pressure. So you end up with low-pressure air above the wing and higher-pressure air below it. The high-pressure air underneath pushes upward on the wing, creating the lift we need to overcome gravity and soar. Now we know that wings create lift, but a plane won't go anywhere just sitting on the runway. It needs a powerful push to get it moving forward through the air. That's where the engines come in. Airplane engines are incredibly powerful. They work by sucking in air at the front, mixing it with fuel, and then pushing it out the back with tremendous force. This powerful push is called thrust. Thrust is the force that propels the airplane forward, making it speed down the runway and into the air. It's what gives the wings the speed they need to start generating that wonderful lift. As the airplane moves forward with thrust, it encounters another invisible force. Have you ever tried to run against a strong wind? It's hard, right? That resistance you feel is similar to a force called drag. Drag is the air pushing back on the airplane, trying to slow it down. Airplane designers work very hard to make planes as sleek and smooth as possible to reduce drag. They want the airplane to slip through the air easily, like a dolphin swimming through water. So for an airplane to fly, its thrust must be strong enough to overcome the slowing force of drag. Flight is a constant balancing act between four main forces. We have gravity pulling the plane down, and lift pushing it up. We have drag trying to slow the plane down, and thrust pushing it forward. When an airplane is cruising at a steady speed and altitude, these forces are in balance. Lift is equal to the plane's weight, and thrust is equal to the drag. The pilot's job is to manage these four forces perfectly, making tiny adjustments to keep the plane flying smoothly and safely on its journey through the sky. This balance is what allows airplanes to fly for such long distances and at such high altitudes. They climb up to where the air is thinner, usually around 30,000 to 40,000 feet high. Up there is less air, which means there is less drag. With less drag to fight against, the engines don't have to work as hard, which helps them save a lot of fuel. This efficiency is why a plane can fly for many hours, crossing entire oceans without needing to stop. It's all about finding that sweet spot where the four forces are perfectly managed. Once an airplane is up in the air, how does the pilot steer it? They can't just turn a steering wheel like in a car. Instead, pilots use special moving parts on the wings and tail to control the plane's direction. These parts are called control surfaces. The main ones are the ailerons, the elevators, and the rudder. Ailerons are small, hinged flaps on the trailing edge of each wing. When one aileron goes up, the other goes down. This change makes one wing lift more and the other lift less, causing the airplane to roll to the left or right, which is the first step in making a turn. To make the airplane's nose point up or down, the pilot uses the elevators. The elevators are the small, hinged flaps on the horizontal part of the airplane's tail. When the pilot pulls back on their control stick, the elevators tilt up. This pushes the tail down and makes the nose of the airplane go up, causing it to climb. If the pilot pushes the stick forward, the elevators tilt down, which lifts the tail and makes the nose point down, causing the plane to descend. It's a very precise way to control the plane's altitude, or how high it is in the sky. The third main control is the rudder. The rudder is the moving part on the big, vertical fin of the tail. It works just like the rudder on a boat. When the pilot pushes on pedals with their feet, the rudder moves from side to side. This movement pushes the tail to the left or right, which helps the airplane turn smoothly without skidding sideways in the air. By using the ailerons, elevators, and rudder together, a pilot can guide the huge airplane with incredible precision, making it bank, turn, climb, and descend exactly as needed to follow its flight path. In modern airplanes, pilots often get some help from very smart computers. This technology is called a fly-by-wire system. Instead of the pilot's controls being connected directly to the control surfaces with cables, they are connected to a computer. When the pilot moves a control, the computer receives the signal and then sends commands to the ailerons, elevators, and rudder. The computer can make tiny, super-fast adjustments to keep the flight smooth and safe, even in bumpy air. It's like having a very smart co-pilot on board helping out at all times. After a long and smooth flight high above the clouds, the airplane has to come back down to Earth. Landing is one of the most careful parts of the entire journey. It's essentially a controlled descent where the pilot must perfectly manage the four forces of flight all the way to the runway. To start descending, the pilot reduces the engine's thrust. With less thrust pushing the plane forward, the plane begins to slow down, and with less speed, the wings generate less lift. This allows gravity to gently pull the airplane downward toward its destination airport. As the airplane gets closer to the ground, the pilot needs to slow it down even more for a safe landing speed. To do this, they use special devices on the wings called flaps and spoilers. Flaps are panels that extend out from the back of the wings, making the wings bigger and changing their shape. This allows the wings to create enough lift to keep the plane flying even at very slow speeds. Spoilers are panels on top of the wings that can be raised to disrupt the airflow, which increases drag and helps the plane slow down and descend more steeply without gaining too much speed. The final moments before touching down are all about precision. The pilot carefully uses the elevators to raise the nose of the plane just before the wheels touch the ground. This is called a flare, and it ensures that the main landing gear at the back touches down first in a gentle, smooth way. Once the wheels are on the runway, the pilot uses the brakes on the wheels, raises the spoilers to their maximum to kill any remaining lift, and sometimes even uses reverse thrust from the engines to help the massive airplane slow down and come to a complete stop. So, flying is a beautiful combination of a few key ideas. It begins with lift, the upward force created by the special shape of the wings moving through the air. It needs thrust, the forward push from the engines that overcomes drag. It requires careful control using ailerons, elevators, and rudder to steer the plane through the sky. And finally, it relies on amazing technology, from the basic science of air pressure to the smart computers in a fly-by-wire system, all working together to make flight safe, efficient, and one of the most incredible things we can do.